I wanted to show you another way of calculating a limiting reactant. This method is what I call a cheater method. So we're going to use this example that I had from a previous video. This is 49 grams given of ammonia and 89 grams given for copper 2 oxide. And how we start is the same. We convert grams to moles, and I'm hoping that that theme is clear to you, that we often convert from grams to moles, if not always. The molar mass of this is 17 grams per mole, and we can calculate that here. 49 divided by 17 gives us 2.88 moles of ammonia. And then here we want to convert from grams to moles for copper 2 oxide, and the molar mass of copper is 63.5 plus oxygen, which is 16, so it's 79.5. Grams cancel here just like grams cancel there, and then 89 divided by 79.5 is 1.12 moles. Now, some of you are really skilled mathematically, and when you look at these mole amounts, you might be able to see which one is limiting, which one will run out first. And sometimes it's easier than others, but it might not be clear to you. And so this is where this little cheater method comes in. What you do is you look at the coefficients in front of each of the substances, and you divide by those coefficients. What we're doing is we're trying to be able to compare them in a 1-to-1 ratio. Right now it's a 2-to-3 ratio, and sometimes it's hard to think, okay, do I have 1.5 times of one versus the other? So this method just allows you to compare them apples to apples. So I'm dividing this because there's 2 of ammonia, I put the 2 here. Because there's 3 of copper 2 oxide, I put the 3 here. And then you need to write in what you get for values. Okay, I just did the bottom one first because I had that on my calculator. This is 0.373. 2.88 divided by 2, well, of course, that's 1.44. Now, what do these numbers mean? The only reason that we would use these numbers is just to figure out which one's limiting. Limiting has the smaller number. So of course it would be that one. But you can't use these numbers for anything else. So copper 2 oxide is our limiting reactant. In this example, it's copper 2 oxide, and I know that because I ended up with a smaller value here originally. But here's advice for you. Don't use those numbers that I just crossed out. Don't use those for anything else. It's just a tool to help you figure out which one of these is going to run out first. Alright, don't tell anyone I told you the cheater method. I might get in trouble for that one.